Be ready with a pen and a paper. All of you be ready with a pen and a paper. During the class, I will ask you some questions. You have to answer to my questions. So please be ready with a pen and a paper. Okay, my children. Right. So today we are going to discuss quadrilaterals, exercise 8.2, question numbers 5, 6, 7. In the previous class, we have discussed the concepts of exercise 8.2. There is only one concept, that is midpoint theorem. Based on that midpoint theorem, this exercise problems were given. I hope you have understood the midpoint theorem well. Haven't you, my dear children? Haven't you? No response from your end? Nobody is responding. Are you listening the class or not?
Yes, sir, we are listening.
Then why are not responding to my question? Now come to the question number 5. In a parallelogram ABCD, E and F are midpoints of sides AB and CD respectively. See the figure 8.31. Show that the line segment AF and EC trisect the diagonal BD. Please read the question carefully, my dear children. In a parallelogram ABCD, E and F are the midpoints of sides AB and CD respectively. Sometimes they will give the figure and sometimes they will not give. Okay, my children. Now observe the figure 8.31. Here 8.31 figure is given, figure 8.31. In this parallelogram ABCD, here point E is the midpoint of side AB and F is the midpoint of side CD respectively. Then we have to show that AF and EC, these two lines trisect the diagonal BD. Do you know what is meant by trisection? Trisect. What is meant by trisect?
Into three equal parts.
Very good. This points P and Q, these 2 points divide this diagonal BD into 3 equal parts. Means we have to show that what is to be shown. Can you tell me what is to be shown? DP length is equal to PQ length is equal to QB length. Understood this point, my dear children? These 3 line segments are of equal length. We have to show that these 3 line segments are of equal length. Now come to the figure. From this figure, what can you say about this figure? This is a parallelogram. So what are the properties of parallelogram? Do you remember? Sides property. What are the properties of parallelogram?
Sir, opposite sides of parallelogram are equal and parallel.
Opposite sides are parallel and equal. So in rough paper, Tell me what are the opposite sides and what are equal. Tell me. In rough paper, write down and tell me. Write down this point on your rough paper. What are opposite sides of this parallelogram and which sides are equal? Tell me.
Sir, FC is equal to AB.
FC?
Equal to AE.
FC equal to AE. Okay. Actually, I am asking about ABCD. I am asking about ABCD parallelogram. In this parallelogram, I am asking about the parallelogram ABCD.
Oh, okay, sir. AB is equal to CD.
AB is equal to CD because it is a pair of opposite sides of the parallelogram. And what is the
AB
second
is
thing?
equal to BC.
BC is equal to AD. Okay. Please write down these points on your rough paper separately. We use these points later. Okay. Right. Now come to the solution part. Come to the solution part. What is given here? ABCD is a parallelogram. It is given that ABCD is a parallelogram. E and F are midpoints of sides, AB and CD respectively. This is a given data. From this data, we have written roughly on rough paper. I said write the properties of parallelogram. This ABCD. AB is equal to CD. You wrote. Have you written, all of you, my children, on your rough paper? I said all of you be ready with a pen and a rough paper. And write question number 5. Write question number 5 and roughly write some information. So AB is parallel to CD and AB is equal to CD. Similarly, BC is equal to AD. BC is parallel to AD. Okay, my children. Write these 2 points on a rough paper, not on a fair class of notes. Now come to this point. Now we have to show that what is to be shown. We have to show that AF and AF and EC trisect the diagonal BD. Here AF and EC, these two line segments are trisecting, means suppose AF intersect BD at P and EC at point Q. Let us consider these are the points of intersection. These are the points of intersection of this diagonal BD and AF and EC. Okay, my children. Right. For our convenience, we have taken like this. Now we have to prove that AF and EC trisect. So come to this point. So from this parallelogram ABCD, we can write AB is parallel to CD and AB is equal to CD. Previously, I told you, you have to write these points on your paper. We use these results later because these two are opposite sides. These two are opposite sides of parallelogram. Yes, sir, my children. These two sides are opposite sides of parallelogram. Similarly, AE is parallel to FC and half of AB is equal to half of CD. Here AE is nothing but it is a part of the side AB and FC is a part of line segment CD. So we can say that A is parallel to FC and half of AB is equal to half of CD because we have written AB is equal to CD. We multiplied this equation on both sides by 1 by 2. What is half of AB? How can you write half of AB? We can write AE. Yes or no? Half of AB is nothing but AE because E is the midpoint of AB. Similarly, half of CD, we can write half of CD as FC. Yes or no? Can we write it or not? This implies AF, AE and FC are parallelized. A is parallel to FC and AE is equal to FC because E and F are midpoints of side AB and CD respectively. So we got here AE is equal to FC. AE is equal to FC. So in this quadrilateral AEFC, if you observe, this is also a quadrilateral AEFC. Yes or no? These are also form a parallelogram. So AEFC is also a parallelogram. Okay, my children. Understood this point? Right. This implies AECF. AECF is a parallelogram. AECF is a parallelogram because AE and CF are parallel lines and they are equal to each other. Okay, my children? Understood this point? Right. Now again, we are taking the same figure, 8.31, to prove the given statement, that is dP is equal to PQ is equal to QB. Now, in triangle DQC, observe the triangle DQC. Observe this triangle only. In this triangle DQC, F is midpoint. Yes or no? F is midpoint of side CD and PF is parallel to CQ. PF is parallel to CQ. Yes or no? So can we use midpoint theorem here? Yes, we can use midpoint theorem. So in the triangle DQC, F is midpoint. F is midpoint of side DC and FP is parallel to CQ. Yes or no? Then we use the midpoint theorem here. P is the midpoint of side DQ. Yes or no? Converse of the midpoint theorem. It is a statement that is a converse of the midpoint theorem. So here we proved dP is equal to PQ because P is a midpoint of DQ. So this implies dP is equal to PQ. Result 1. Let us consider this is result 1. Okay, my children. Similarly, let us take another triangle, that is triangle DAB. Let us take that triangle DAB. Similarly, in triangle APB, or we can take APB also in triangle APB. In triangle APB, observe this triangle APB. In this triangle APB, here E is the midpoint. E is the midpoint of side AB. E is the midpoint of side AB, and here EQ is parallel to AP. Yes or no? EQ is parallel to AP. Then we can say that PQ is equal to QB. By the converse of the midpoint theorem, we can write this result. Okay, my children, here E is midpoint. E is midpoint of side AB, and EQ is parallel to AP, as AF is parallel to EC. So here also we use converse of the midpoint theorem. Q is the midpoint of PB. Q is the midpoint of PB because by using the converse of midpoint theorem, we can write this statement. Since Q is the midpoint of PB, we can write this statement as an equation. Q is the midpoint of PB. How can you write? PQ is equal to QB. Yes or no? PQ is equal to QB. We can write this statement in the form of an equation as PQ is equal to QB. Let us consider this is a result 2. If we observe the result 1, dP is equal to PQ. If you observe the result 2, PQ is equal to QB. So dP is equal to PQ and PQ is equal to QB. So can we write dP is equal to PQ is equal to QB? Can we write it or not? From 1 and 2, from the equations 1 and 2, here type mistake, I will correct it later. dP is equal to PQ is equal to QB. Here from the equations 1 and 2, not 1, by mistake here 1 only typed, I will correct it later. So from equations 1 and 2, we proved here dP is equal to PQ is equal to PQ. That means AF and EC trisecting the diagonal BD. Finally, we can write this conclusion. Hence proved. Hence the line segments AF and EC trisect the diagonal BD. Okay, my children, right. Hence prove. Hence prove. Now let us come to the next question. Understood this question, my dear children? Understood this one? Question number 5. Understood this question number 5? Here we use converse of the midpoint theorem. Nobody is responding. Yes, Harini responded.
Yes, sir.
Understood, sir.
Yes,
Understood, sir.
I will post
Understood, sir.
this PPT in the form of PDF in the Google Classroom. Find out. Only few students are writing the classwork notes. Only few students are writing the classwork notes. You have to submit your classwork notes completely. No pending. Okay, my children. I am posting the classwork notes every day. Most of the cases, I am posting the classwork notes in the form of PDF. I will ask you, otherwise I will call your parents and ask you why they are not writing the classwork notes. I am providing the classwork notes in the form of PDF every day in the Google Classroom, but your word is not writing. I will ask you in front of your parents. Okay, understood? Right. Now come to the next question. Question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Here we have to show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Sometimes they will give a rough diagram, and sometimes we have to draw the rough diagram. It is mandatory for any geometrical related question. Any geometry related question, you must draw a rough diagram. Please remember this point. Okay, Medicine. Right. See here, this is a rough diagram for the given data. Let us consider ABCD is a quadrilateral. ABCD is a quadrilateral in which S, R, Q, P. These points P, Q, R, S. These are the midpoints of the sides AB, BC, CD and DA respectively. We have taken these 4 points or midpoints of the 4 sides respectively. Now we have to show that if you join these midpoints, what is should be done? The line segment joining the midpoints. If you join these midpoints P, Q, R, S, we get a quadrilateral. Okay. Then opposite sides means PQ is equal to SR. The opposite sides of quadrilateral bisect each other. Okay, we have to show this one. Joining the midpoints of the opposite sides of the quadrilateral bisect each other. Understood this point, my children? Right. Now come to the solution part. Let us consider ABCD is a quadrilateral. ABCD is a quadrilateral and P, Q, R and S are the midpoints of sides AB, BC, CD and DA respectively. Okay, my children, this is given to us. What is to be proved if we join the PR and QS? If we join PR and QS, then these 2 line segments are bisecting each other. They bisect each other. PR line segment and SQ line segment, they will bisect each other. Okay, my children, right. Now, in triangle ACD, observe the triangle ACD, down triangle, downside triangle, in triangle ACD. Okay, right. What do you observe here? In triangle ACD, what will you observe here? S is a midpoint. Yes or no? S is a midpoint of side AD. Yes or no? R is a midpoint. R is the midpoint of CD. Or S is the midpoint of AD. Both are midpoints of the sides CD and DA respectively. Okay, my children, have you observed this figure carefully? So SR is parallel to AC. SR is parallel to AC. SR is parallel to AC. In this triangle ACD, these two are midpoints. We join these two midpoints. So by the midpoint P down, we can say that this line segment SR is parallel to AC. Okay, my children? Right. Similarly, we can prove that. Similarly, we can show that PQ is parallel to AC. Similarly, we can prove that PQ is parallel to AC, PS is parallel to BD, and QR is parallel to BD. Okay, my children, we can prove like this by taking the triangles. It is enough to show that first one, and we can write this statement. Similarly, we can show that PQ is parallel to AC, PS is parallel to BD, and QR is parallel to BD. Observe this quadrilateral, my children. Then PQRS is a parallelogram. If you observe this quadrilateral PQRS is a parallelogram. Then automatically, because they are opposite sides and they are equal, so in this quadrilateral PQRS, the opposite sides are parallel and equal. That is why this quadrilateral PQRS is a parallelogram. PR and QS are the diagonals of the parallelogram. Yes or no? If you observe these PR and QS line segments carefully, my children, PR and QS, these two are diagonals of this quadrilateral, this parallelogram ABCD. You know that what is the diagonal property of a parallelogram? Yes. The diagonals of a parallelogram bisect each other. Yes or no? So they will bisect each other. That is only required statement. Required. It is to be proved. Hence proved. Okay, my children. Now come to the question number 7. Now come to the question number 7. ABC is a triangle, and in this triangle, at angle C, a right angle is formed. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that D is the midpoint of AC, and second part MD is perpendicular to AC, and the third part CM is equal to MA, that is equal to half of AB. So we have to prove these three statements. So for this also sometimes they will give a rough diagram, otherwise we have to draw a rough diagram. So observe this rough diagram, my children. ABC is a right angled triangle. ABC is a right angled triangle, and 90 degrees. A right angle is formed at the vertex C. Here M is the midpoint of AB. Here the point M is midpoint of AB and parallel to BC. And this line intersects AC at D. We have to show that D is midpoint of AC. And MD is perpendicular to AC. And third part, CM is equal to MA is equal to half of AB. We have to prove all these three statements. Okay, my children. Right. Now come to the solution part. In triangle ACB, in triangle ACB. M is the midpoint of AB and MD is parallel to BC. It is already given. Okay. So by using the midpoint theorem, we can say that D is the midpoint of AC. That implies D is the midpoint of AC by the converse of midpoint theorem. By the converse of midpoint theorem. So the first part of the question is over. What is the first part of the question? We have to show that D is the midpoint of AC. So we have proved D is the midpoint of AC with the help of converse of the midpoint theorem. Now come to the second part. We have to prove that MD is perpendicular to AC. Here, angle ACB is equal to angle ADM. Observe this figure, my children. Angle ACB is equal to angle ADM. Because these two angles are corresponding angles. BC and MD are parallel lines. In that case, these two angles, ADM and ACB, are said to be corresponding angles. You know that if two lines are parallel lines, corresponding angles are equal. Yes or no? This implies also angle ACB is equal to 90 degrees. Also angle ACB is equal to 90 degrees. Therefore, angle ADM is equal to 90 degrees and MD is perpendicular to AC. We proved here second statement. Here we proved angle ADM is 90 degrees. Here ADM is 90 degrees. That implies we can say that MD is perpendicular to AC. That is the second part of the question. Now come to the third part. We have to prove that third part, CM is equal to MA is equal to half of AB. Again, we have taken the same figure. Now come to the third part. In triangle AMD, let us take the triangle AMD. Observe this triangle AMD and CMD. AMD and CMD. We have taken these two triangles, left side triangle and right side triangle. Okay, Mansilan. Right. AD is equal to CD. Yes or no? Because D is a midpoint of AC. D is a midpoint of AC. We can say that CD is equal to AD or AD is equal to CD. And which parts are equal? Angle CDM is equal to angle MDA, that is 90 degrees. Yes or no? Each angle is 90 degrees. Angle ADM is equal to angle CDM. Each angle is 90 degrees. Now DM is equal to DM. It is a common side. Which part of these two triangles are compared? Now can you tell me? Which criteria is used to show that these two triangles are congruent? Which parts of the
Sir, AAS.
A
Sir, angle on the side.
side, angle, side angle. Here we have taken one side, one
Sir,
angle
side.
and side angle, side. By using this congruency criteria, we can say that triangle AMD is congruent to triangle CMD by SAS congruency rule. So then by CPCT, can we write which parts can be equated? AM is equal to CM. Can we write it or not? AM is equal to CM by CPCT. By CPCT, AM is equal to CM. Also, AM is equal to half of AB because M is a midpoint. Because M is a midpoint of AB. Yes or no, my children? Hence, prove. That is also proof. Third part, CM is equal to MA is equal to half of AB. That is the third part of the question. All the three parts were proved. Okay, my children? Right. Okay, my children? Please write the classwork notes completely and submit your classwork notes. If anyone ignores in submitting your classwork notes, you will face problems. In future, you will face problems. Okay, my children. Now the time is 9 past 41 minutes. 9 past 41 minutes. You can start writing. Only 4 students submitted for the last class. If I observed, what 46?
Sir, it is 9:47 now.
9:47. Okay. Then you can leave the meeting. Now you can leave the meeting.
Thank you, sir.
Okay. Okay. Thank you. Thank you all, my
Thank
children.
you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, Samik. What, Rinsan? Kavya? Kavya? Still you are online? You also can leave the meeting. You also can leave the meeting.